Okay, in this video we'll look at definite integrals as the limit of a Riemann sum. Here's the AP standard for today. The definite integral of a continuous function f over the interval from a to b, denoted by that, is the limit of a Riemann sum as the widths of the subintervals approach 0. So we can write a definite integral as the limit as delta x goes to 0 of the sum from I equals 1 to n of f of x I times delta x. N, in this case, is the number of subintervals. Delta xi is the width of the ith subinterval, and xi, with that star on it, is a value in the ith subinterval. Alright, so let's unpack what all that means. First, let's recall a few things that you learned previously in this course, and also something that you learned back in algebra. First is what that sign means. The funny looking E. That's actually the capital form of the Greek letter sigma. In math, this means just to add everything up, or to find the sum of things. This would be read as the sum from k equals 1 to n of k squared. And that just means that we want to plug in different values for the k, starting from 1 all the way up until n, and then add up all those terms. That would give us 1 squared plus 2 squared plus 3 squared, and so on and so forth, all the way up until you get to n squared. And finally, we can define delta x as being b minus a divided by n. So you might remember that a Riemann sum can be used to estimate the area under a curve. If we only have a few rectangles, then we're not going to have a very good estimate. If we increase the number of rectangles, we'll get a better estimate for the area under a curve. If we keep increasing the number of rectangles, notice that delta x, the width of each rectangle, is getting smaller and smaller, and our area keeps getting better and better. Okay, so what have we figured out so far? We know that Riemann sums can be used to estimate the area under the curve, and the area under the curve really is just a definite integral. When using only a few rectangles, the estimate isn't going to be very good. But as we increase n, which is the number of rectangles, the estimate is going to get better and better. In order to get the best estimate, we can create an infinite number of rectangles. So in order to do that, we need to do the limit as n goes to infinity of the sum of the rectangles. So as that happens, keeping in mind that delta x is equal to b minus a over n, as n goes to infinity, the denominator for delta x goes to infinity, and therefore delta x itself is going to go to 0. So as n goes to infinity, the width of each rectangle goes to 0. And the formula that brings all this together is this. The integral from a to b of f of x dx is equal to the limit as n goes to infinity of the sum from k equals 1 to n of f of a plus k delta x times delta x. The dx inside of the integral stands for delta x inside of that sum. The lower boundary for the integral a is the same as the a that's sitting right there. Here's a few examples of how we would work out these types of problems. You need to know how to go both ways. If you start with an integral, find the limit of the Riemann sums, or if you're given the limit of Riemann sums, then you want to find the integral. Here we start with the integral from 0 to 3 of x squared minus 1 dx. This is telling us that a is equal to 0, b is equal to 3, and that our function is x squared minus 1. In order to solve these problems, just follow these 4 steps. First, we want to find delta x. And we're going to use the delta x formula from before. Delta x is equal to b minus a divided by n. Well, we're given that b is equal to 3, a is equal to 0. So b minus a over n would be 3 minus 0 over n. This would simplify to 3 over n. Step 2, we want to find a plus k delta x. So a plus k delta x, we know that a is equal to 0, and we found delta x in the previous step. That was 3 over n. Notice that since a was 0, we only have a single term here. If a was not 0, we would have two terms for the a plus k delta x. Step 3, find f of a plus k delta x. So we just want to plug in our a plus k delta x, which is 3k over n, into the f of x formula, which was x squared minus 1. That would give us 3k over n squared minus 1. Step 4, we just want to use the formula to bring everything together. So the definite integral that we started with, the integral from 0 to 3 of x squared minus 1 dx, would be equal to the limit as n goes to 0 of the sum from k equals 1 to n, and then we have a bracket with 3k over n squared minus 1 inside the bracket, and then outside the bracket is our delta x, 3k over n. Just follow these 4 steps every time, and you'll always be able to answer these problems. Let's try one going the other way. We want to start with the limit of Riemann sums and find the definite integral that equals. Inside of the bracket, after the sum, that is our a plus k delta x. Being multiplied outside of that bracket, that is our delta x. Notice there's no k inside of the delta x term. Step 1, as before, is we want to find delta x. Well, delta x was given to us in this problem. That was just equal to 1 over n. Take note that the numerator of this is b minus a, so the difference between b and a is just equal to 1. Step 2, we want to find a plus k delta x. To do this, just look inside of the parentheses from the f of a plus k delta x section of the limit of the Riemann sums. Inside of those parentheses are just k over n. So that is our a plus k delta x term. It's important to notice that we only have a single term here. That means that our a value has to be equal to 0. If you had 2 terms, then your a would be whatever the constant term was. Step 3, we want to find f of a plus k delta x. Well, we already know that that was the 2 times k over n squared plus k over n. But now that we know that the a plus k delta x was k over n, that means that those 2 parentheses will have to be our x terms for f of x. And finally, step 4 is we just want to bring everything together and show what the definite integral is equal to. This would be equal to the integral from a to b, so in this case it goes from 0 to 1, of f of x, which is x squared plus x dx.